Okay, so here we've got kind of an introduction to some of our probability and statistics stuff. So we're going to start with this factorial notation. You may or may not have seen this before, this exclamation point. It means factorial. So you should be able to find this in your calculator under math. So if you press the math button and you scroll over to get to probability, you'll see that you have these three things here, which are what we're going to use today. So starting with that exclamation point, you should be able to get the value, but knowing where it comes from is also important. So the factorial means that you're going to start with the number that's in front of the exclamation point and then multiply all the way down to 1. So 3 times 2 times 1 is what it's telling you, which is just going to be 6. If I do it with 15, now I've got even more to do. I've got 15 times 14 times 13 times 12 times 11 times 10 times 9 times 8, 7, 6, 5, 4, 3, 2, and 1. This is where your calculator is going to come in. I mean, you can multiply all of this out, but if I just put this in my calculator as 15, I go and grab the exclamation point, I should be able to get this value here, which in this case is going to be very large. Your calculator gives you 1.3 E12, which hopefully you know is 1.3 times 10 to the 12th. So we've got a very large number for this. The other silly thing that you have here is your 0 factorial, and if you try this in your calculator, it'll tell you what's happening here, but it's actually going to be 1. So your 0 factorial actually equals 1. It's not 0. It goes above and to that point of 1. The other thing that we can do here is to simplify. Now I can write this out all the way through. I'm going to stop here at 13 because I have this 13 on the bottom. So here I have 20, 19, 18, all the way down for my 20 factorial. I can use this notation and stop whenever I want. The reason I stopped at 13 is because I have 13 factorial at the bottom. Both of these are saying 13 times 12 times 11 times 10 times 9 times 8, etc. When I'm using multiplication and I have division, these are going to cancel out, which means that I'm left with just the beginning part of this, that 20 times 19 times 18, 17, 16, 15, 14, which is going to equal 390,700,800. Still a very big number, but you can also do this in your calculator with the division, but this is what it's actually looking like when you go to do some problem solving. We've got some calculator stuff. Let's look at where we can go from here. So for using our factorial notation, we've got 8 runners in a race to determine who advances to the state championship. And how many different orders can they cross the finish line? So we've got the fact that there's 8 runners here. Okay, the 8th person could be first. Okay, the 7th person could be first, and these are just their like running numbers. Okay, we could go on and on and on. You can go all the way down, which means that when we're talking about the chances or the orders that these could come in, we actually use a factorial. So what's going to happen here is you've got 8 factorial, which means this person could be first, number 8, number 7 could be first, number 6. All of these have the options of being first, which means that you've got 40,820 different orders that these people could all come in. If the 8th person comes first, and then the 7th, and then the 6th, or if we had some different order there's over 40,000 different ways that this can happen. Now, we don't always care about all of these people, unfortunately, and how they all cross the finish line. It's actually more important to us the first couple people. So that's why we have this thing called permutation. So it's a big word for the order or the arrangement. And in this case here, the order matters. So we're talking about people coming in first, second, third. We want a winner in this case here, or we want to listen to our songs in a certain order. The order of how things come out matters. You want your appetizer before your dessert, etc. So if we're thinking about the runners, we do care, so it does matter about the order that they come in, because we want to know who's first, second, and third. We want to be able to give them those medals. So what happens here is we have this 8 factorial as 8 times 7, 6, 5, 4, 3, 2, and 1, but we really only care about this part of it here. These people who came in first, second, and third, which means we've got to get rid of the rest of this. As we saw before, to do that, we were talking about division. So that means we have 8 factorial over 5 factorial. This part right here is that 5 factorial, and this is how you get a permutation, is you are subtracting on the bottom. So really you have your 8 factorial over 8 minus 3. So I've got 3 things that I'm dealing with, first, second, and third. 8 minus 3, I do this part first, which gives me that 5 factorial. Okay, and what this is saying here, underneath you've got your notations, is that we see this notation here which says NPR as subscript. So it's a permutation of n objects r at a time. So n, this one's always the bigger one. It's your total that you're dealing with. And then r is smaller, and this is the order or how many you want. You can see in your calculator, you can find it here under the math button again, so we don't always need to do out the math for this. We can actually go and find it in our calculator and continue from there. Okay, so this one would look like 8 permutations of 3. Okay, 8 runners. We're talking about putting them in order 3 different ways. Okay, we'll look at one more. So you just downloaded 5 new songs to your iPhone and are eager to listen to them. How many different orders can you play them in? So we're looking at ordering them in a specific order for this. Or we don't care. We're not caring about this. We're just, this one's like an example of the one before. So we've just got 5 factorial, which is going to give us 120 different orders. Okay, so we've just got one number that we're dealing with. We want to figure out what we can do. Okay, this one here, when we take our iPod to the beach, we have our 10 favorite songs here. You'll be there long enough to listen to 6 of them. How many different orders can you get them in? Okay, so here we're looking at taking that 10 permutations of 6. Okay, so that looks like algebraically like this. So 10 factorial over 4 factorial. But we can put this right into your calculator. So you want to go math, scroll over until you're at probability, and then you can see that you want to go down to the NPR. Now you need to enter this number first. So enter 10 and then enter the 4. So you will need to do this first. You might need to do the 10 first before you even go to math, and then enter the 4 afterwards, or the newer calculators allow you to put it in after you've gone and pressed the button. So you need to ask someone where that needs to go. Okay. The other thing that we need to look at is there's not only permutations, there's combinations. So in combinations, sometimes we don't care what order things, we don't care about the order that they're in. So when we don't care, we call it a combination. So don't care about the order. So even the songs probably could have been more of a combination when you just press shuffle. We're kind of just looking at them how they need to go. So the 8 runners came in first, second, and third, and we had it as 8 permutations of 3. When we don't care, the equation looks like this. Now luckily this is under math as well. So we can go math over to probability and then choose NCR. So combinations of n objects at one time. Okay. So if we just practice, this is good practice here for your calculator. You might have to type this in first. So type 9, then go to math, go over to probability, and you can see that you're going to choose this one, 3, which should bring you back to your home screen, and then you fill in the 4. Okay, and that should get you, this one should get you 126. Make sure you practice this. This should get you 253, and this should give you 6,435. So this is a time to stop and check these on your calculator before you move on to make sure you're using your calculator correctly. Okay, this is a good page perhaps to write down. When should you use one? Because that's what you're going to have to be able to decide. When do I use a permutation? When do I use a combination? Do I care about the order of things happening? So are we talking about gold versus silver or bronze? Or is it just a friendly 5K and we're just looking at who comes in any time at all? So we don't care who is going to be first, second, or third. Or do I care which ones are chosen? If it's only the selection that matters, we're using a combination. We pick groups in class. It doesn't matter who is in what group or what order people are picked in. We're just trying to make groups. So here we're just trying to make groups. Then we're talking about a combination. If we want a winner, really, we're talking about a permutation. Okay, so some quick stuff with that. So here, suppose you invite 3 friends to a concert with you. If you choose Jay, Ted, and Ken, that's no different than Ted, Ken, and Jay. So there's no winner. The order that you choose, the 3 names, is not important. So it was the 3 friends were from a group of 5 that wanted to go. How many different options did you have? So this is using a combination where this is going to be 5 combinations of 3. Okay, so this is still your bigger value in front, just like with the permutations. And you can put this right into your calculator. Technically, the formula says that it's 5 factorial over 3 factorial times 5 minus 3 factorial, which would be 5 factorial over 3 factorial times 2 factorial. And we would have to do all of this out. But you should be able to do this in your calculator and get the fact that there was 10 combinations that you could have had. So of those 5 people, choosing 3 of them to go with you actually posed a pretty big situation for you. 10 different ways you could have picked those 3 people. Jay, Ted, Ken, Jay. It could have been the other people thrown in there as well. We could do a whole tree to get to it. But that's a lot of work, and this makes it a lot easier for us.